So we just learned how to solve an inequality by shading the proper region and having a boundary line. Okay, now we're going to take that same application and solve systems of inequalities, meaning that we're going to solve two or more at the same time. So here's an example of what it is that we're looking for. And I have a system of linear inequalities. I have y is less than 2x minus 3, and then I have 2x plus y is greater than or equal to 2. So here's what we're going to do. All right, we're going to graph these individually by hand and then check to make sure that we're doing it correctly and talk about it. Okay. So my first one here, I'm going to graph, this is x, this is y. I'm going to do it in black. Less than 2x minus 3. So I'm going to go up to 3. 1, 2, 3. And my slope is positive 2, so up 2 over 1. And I would have a dashed line here. So down 2 over 1. And the reason I would have a dashed line is because my boundary line is less than or equal to. Okay, now, which way do I shade? To the left or to the right?
Well, you should shade
How do I do it?
to the left. To the left.
Okay, take a test point, right? Take the test point 0, 0, just for an example. Is 0 less than negative 3? Oh, I graphed plus 3. I graphed plus 3. Here, let's just do this. I graphed a positive 3. There we go. Okay. Okay, now, yeah. Y is, I want less than 2x plus 3. So now, yeah, I changed the 3 to, as I graphed the wrong line. Because it should have been a plus 3 in my notes. So I have y is less than 2x plus 3. So which way do I shade now? I shade to the right now. Very good. Okay, so now it all makes sense. Okay, so I want everything in this direction. Okay, so I'm gonna try and do a pretty good job here of shading all this stuff. Okay, that's pretty good. That's not bad. Big highlighter there. Okay, now the next one I'm gonna do in purple, and I have 2x plus y is greater than or equal to 2. So I want y is greater than or equal to negative 2x plus 2. Okay, let's not mess this one up. So if I go up to positive 2, 1, 2, and then I go down 2, and I go over 1. Down 2 and over 1. And do I shade, or sorry, is my line solid or dashed? It's going to be a solid line. So I go solid line right here. Okay, now which way do I shade? Test 0, 0, right? Is 0 bigger than 2? True or false?
No, solid.
False. So I don't shade that way. I shade the other direction, right? So I'm going to go ahead and choose yellow. And I want to shade everything that is to the right of my purple line, right? Oh. Whoa. What just happened there? Okay, what's going on here? This is crazy town. I don't know. So, I chose these colors for this fun reason here, right? So, what are we noticing here?
It's neon green.
Yeah, okay, so I have a blue boundary, and I have a yellow boundary, and then I have a green boundary. So, what's the boundary that I'm really interested in? The green one. Why the green one, you guys?
Because it's everything for both of them.
It's everything for both of them. Well, you're absolutely correct. It's everything for both. Okay, so let's...
Do we need to use different colors and stuff like that?
Yeah, you guys can use highlighters, or you can use different shadings. Like you can shade one way and then shade the other way. I'll show you. All right, let's make sure we're doing it right. I have y was greater. I don't even know what I had. What did I have? Y was greater. Nope, sorry. Less than 2x plus 3. Okay, I can do that. Let's go back. Let's go back. Let's go back. Back. Y is less than 2x plus 3. So 2x plus 3. Okay? There's my first line. Perfect. And then my other line was 2x plus y is greater than or equal to 2. Okay, no problem. So 2x plus a y is greater than or equal to 2. Boom. Okay, there we go. Okay, so just like we had, notice that we have a red region, we have a blue region, and then we have the overlap, which is a purple region, okay? So the one that we're interested in is the overlapping of the two regions, the region that makes the most sense, the region that makes both inequalities true. Okay? So give me a point in the region that would work for the system. Any point.
5, 0. Yeah.
5, 0 would work. 5, 0.
10, 0.
Yep, that works. Give me a point that would not work.
Negative 5, 0.
-5, 5. Put that one. This one definitely would not work. It doesn't make any of them true, right? So you could figure out which points work for none, one, or both. And the one that we want is the one that solves for both. So back in our little equation here. Oh, sorry. Yep. Any point in this region in the highlighted group is going to work for us. Okay, everybody look at the screen. Here you go. Okay, open your eyes and look at the screen. Okay, here's your task. Your task is to figure out the system. Figure out the system that I wrote to come up with that graph. Okay, ready, set, go. Daniel, what did you guys come up with for your system?
Y is less than negative 1 over 2 x plus 5.
Y is less than -1/2x plus 5. And what was the other one you came up with?
Y is greater than or equal to x minus 1.
That is correct. Nicely done, buddy. Okay, graph that system by hand using your pencil, then check it on Desmos or your graphing calculator.
6.6.
Okay, hopefully you solved this and your graph looked something like this. Is that true?
Yes.
Both of them were dashed, right? And the boundary, the region, the dark region is sort of this region over here to the right. You have like orange and then the black and this region over here to the right. Okay.